Hello folks, today we're going to do practicum number 4, which is where we're going to show how to use the variety of different pipettes, pipette bulbs, and volumetric flask. One of the first things we're going to make the assumption on is that the pipettes have already been washed with soap, so we're not going to bother to wash with soap. But once again, we will go ahead and wash with our tap water and at least wash with deionized water. So the first thing we're going to use is our volumetric pipette. The idea here is this volumetric pipette, see it's labeled 10. When I fill this up to the line, which is right here, that is exactly at 10 milliliters. And as we use that, we're going to use this pipette bulb here. So this pipette bulb has 3 buttons. We have A up here, which we use when we squeeze. If I am not pressing either of these 3 valves, I can squeeze this all I want. It's not going to stay depressed. So the A will allow us to squeeze that, and it's separating these chambers from that chamber. When I hold this one down here, which is our S, it will allow this bulb to fill back up as it sucks up through there. And this last one, which is E, is for empty. That will be to empty the pipette when we're ready. So first thing is to rinse the pipette with deionized water. The simplest way to do this is we can from the top squirt deionized water down here and let it twist. The idea, we're just coating the sides with deionized water, letting that drain. This is to clean the pipette, whatever was in here. Now the next step is, before I fill this up, this is very important, to rinse with our analyte. Our analyte is our reagent that is going to go in there. So to rinse it, I'm going to first press the A and squeeze the bulb, so you can see the bulb is depressed. I am going to dip this into my green solution. Make sure it's fully submerged. And I'm gonna press the S and suck a small amount up. Please note, I'm not sucking the full 10 mils up. I only need enough to coat the walls. So then I can roll this on the side, the idea being I can even then press suck just a little bit just to get it into up here. The idea is we're coating the walls with our analyte. Then I'm going to go back and press the E and let this drain all the way back out. Drain all the way back out. So every time, we will always be washing this with our analyte prior to filling this all the way up. So I'm gonna, as I dip this in here, I'm gonna make sure it's fully submerged. If it is not fully submerged, I'm gonna get air bubbles. That's the number one no-no as I fill this up. We do not want any air bubbles anywhere in here. If you get air bubbles, you may have to evacuate this back out. So make sure it's fully submerged. I'm holding the S until it fills up. Okay, now see, it's gone a little bit past the line. The line is right there. That's a little bit past. Oh, this one's draining back out. I'm gonna make sure this is that I have fully put this bulb on. the glass part is only up to about right here. I don't want to push it too far or else it's not going to work. If I push the glass all the way into the S, it's going to break that valve. So I need to get all the air bubbles out and get it right at the meniscus. Right at the meniscus. So I'm going to feather the E. Let it slowly drain and try to get it so the meniscus is, the bottom of that bubble is right on the line. If I shoot past just a little bit, I will need to suck a little bit more back up. But the idea is to get that air bubble as close as we can to that line. I just want to pull that up. Once that is there, I'm going to move this to our graduated cylinder and drain completely my 10 mils. I'm just holding the E, letting it drain. I'm holding the E, letting it drain. Now please note, this is a highly calibrated pipette. I do not need to blow out the tip. There is maybe a little droplet in there, little droplet in the tip. Maybe there's some, maybe there's not much, but I only need to hit the E. And once I've drained that, that should be exactly 10 mils. I do not need to suck up any more or blow it any more. We do not want to blow out the tip. And then I will weigh this and be able to tell you how accurately you measured this based on the weight, because of the density of water. If I weigh the flask beforehand, I can weigh it afterwards. Now the next guy, we're going to have a volumetric flask and a graduated serological pipette and a micropipette. The next thing you should do is rinse out the volumetric flask. To do this, we're going to just rinse it with a small amount of water. We don't need much. Just rinse it with a little bit of deionized water that can go into the waste. Now, here's the key. We do not wash this with the analyte. The key here is we only wash, the last wash will always be the thing that should be the majority component. Now, in here, we're trying to get green dye solution. And here, the idea the majority component should be water. So we're going to dilute this with water. So we're going to try to get an exact quantity of green dye in here. And we don't need, if you rinse this with a little bit of green dye solution, you're going to have a little bit of extra green dye. So we will not rinse this with green dye, we'll rinse it with water. The next step is to use the serological pipette. The serological graduated pipette, you'll notice, has lines 0, and this one actually ends up at 9 something. The idea that this is calibrated to some extent so that when you blow out the tip, you get 10 mils. So, but if I wanted to get 8 mils, I would suck up to the 2 and I can drain it down to the 10. Or I could suck it up to the 0 and try to drain it down to the 8. It's actually going to be probably much easier just to go from the 2 to the 10 to get 8, because trying to stop this at a certain volume is oftentimes very tricky. We're going to use a different type of bulb. This is the suction tip, where when we insert the pipette into here, when I twist this down like that, it will, as that pumps up, that will create suction. I can press that to release and let it drain back out, or alternatively I can push this down to release this back out. So following the same steps, I'm gonna rinse this with deionized water. Since there's no big bulb, I can just twist that and drain some water through that. I'm going to now suck up some green solution. Don't need much. Let me put this on the side and just suck up. The key is to make sure I don't get it into the tip, but and that's going to go into the waste. I make sure I don't get it all the way up into the bulb. If I get into the bulb, that problems could happen. Now, I'm gonna try to pipette it in 7 mils. So I'm gonna suck up to the 3, get it right, so the meniscus is right on the 3 as best I can. And I'm gonna put this, I got a little bit of bubbles, so let's try to blow those bubbles up. Some bubbles in the tip. Yeah. Trying to get rid of the bubbles, as the bubbles could potentially will potentially throw off the volume. So get it right where I want it. Right at the 3. Oh, it's a little bit lower, so let's bubble. So, sorry if it's a little bit off camera, but I'm trying to get right at the 3. No bubbles in the tip. Insert this. I can just hit the drain. I'm holding the drain button way. Okay, and here's the key. So I hit that drain, but the serological pipette is calibrated so that you want to blow out the tip. So to do that, the serological pipette is calibrated so you want to blow out the tip. So in order to do that, I need to just press that down. I'm blowing out by squeezing down on the final thing. So I squeeze that down. I'm blowing out any remainders out of the tip. Any remainders out of the tip. That will make sure I have exactly the 7 mils. Now the last thing we're going to do before we make our dilution is use the pipette, the micropipette. Micropipette has a couple key features. We have a dial that dials in the amount of sucked up. You want to be gentle with this. You don't have to be super light, but we want to twist this slowly because it's calibrated. We have a ejection button that should eject the tip, and we have the pipette button. So as we press this down, you'll see how this is not all the way depressed. This is the first resistance point, and then we have a second resistance point all the way down. So we got to keep in mind those 2 different points as we suck up a liquid. That this is, if done right, this is calibrated so that we will dispense exactly whatever volume it's measured for that. So the first thing I'm going to do is twist this to 800. So this is saying I'm going to pull up 800 microliters. You do not have to rinse this because each time we will be using a tip, a pipette tip. So right here, so I'm gonna plunge this in. And it's going to be our pipette tip. Ideally, you're going to have a fresh pipette tip each time. Our sake, we can keep reusing the same pipette tip. So I'm going to then submerge the pipette into the water, into our green dye. I'm going to press down to the first resistance point. Nothing should have happened. I've just blown air out. But as I release slowly, it will suck in some liquid, approximately 800 microliters. I'm going to see how I tapped this to get any droplets off. Now, as I put this in here, I'm going to press it down slowly, then completely depress it, and so that all liquid should have been shot out. So I've completely depressed it, so to remove all liquid from in there. From there, I should be able to just eject this back into either into the waste or inject that, or we can use that again. So the last step before we do our calculations is to finish the dilution. So we have right now 7.8 milliliters of green dye in this 10 ml flask. 7.8 milliliters. We will go ahead and add deionized water up to the 10. So I'm just slowly, carefully adding. We want to make sure that we get it right at the line. Go slow, because once you add too much, you cannot unadd. The idea is that you want it. I just need just another drop. Okay, I think that's as good as it's going to get. I might have actually gone just a pinch overboard. Can't do anything else. The next step is parafilm. We're going to parafilm this. Sometimes you can use a stopper, but right now we have parafilm. That's our option. So parafilm is a piece of wax film that we use to coat the flask. So step one, I fold in half. Then pinching from one side, I stretch it over. See, wax, it stretches. And then I'm going to start twisting around, making sure I'm both over the lip and over the top. If it breaks, you can just retwist it, readjust it, keep twisting. The idea is we have a nice airtight seal. So now when I go to invert it, no liquid is spilled. Some might catch in the lid, but none is spilled. So we do that several times, and we got our sample. It's been diluted from 7.8 to 10 milliliters. The last thing we must do is a quick calculation. So, using the idea of M1V1 equals M2V2. Our M1, I will give you. M1, we'll say it's 5 molar. Our V1, how much green dye did we use? We used 7.8 mils. Our V2, what's our new volume? Well, this is a 10 mil flask, so we diluted to 10 mils. So the question is, what is our M2? So 5M times 7.8 milliliters equals M2 times 10 milliliters. Now, to solve this, so 5 times 7.8, we have to divide the 10 from both sides. When we divide the 10, our new molarity is 3.9. So I divide both sides by 10 mils. 10 mils, and so my M2 would be 3.9 molar. And that is what you would need to do for practicum number 4.